Good day. This is Reynan J. Pablo, student number 24. This report focuses on different black box models used in hydrology. Black box models are used to simulate models in studying hydrological cycles for water management. In water management, a hydrologic black box model creates models of the water inflows and outflows of the system that could be used for water resource, transportation, distribution, storage, researches, and flood routing. In general, the black box model is a term used in different fields of sciences through having same basic concept that simply describes any sort of model or system in which input can be entered or observed and output can be gathered or received. But the processing takes place unseen. The black box model is often used in computer programming, financial planning, and study of human behavior, but this paper discusses its application in hydrological cycle. Water cycle is the common term to describe hydrology. Before rainwater can flow in a stream or channel, it must first descend from the atmosphere, go across the surface of the land, and accumulate into concentrated form. The scientific term for this is hydrologic cycle, where it recycles the water that flows in streams, comes from the ocean, and is returned again in a constant cycle. The following figures describe the hydrologic process. There is a need to understand first the concept of watershed before discussing about the black box model. Watershed is a very complex area that involves different variables and factors to consider to create a better model because of its vastness and different processes are hidden under the ground or seemingly unpredictable. Watershed is a large area of land that drains water from precipitation or from man-made consumption, including sediments and dissolved materials, to a common receiving body of water or outlet, such as river, sea, lake, catch basin, or reservoir. Watershed may usually cross political boundaries or administrative regions. The scene or people collaborating for environmental and economic management reported that Davao City has 8 watersheds shown in Figure 3. However, the Talomo and Lipadas watersheds, collectively known as Talomo-Lipadas Watershed or TLW, have the highest quality of water for human consumption, originating from the eastern slopes of Mount Apo and Mount Talomo. Although the Talomo-Lipadas watershed covers only 12% of the city's land area, it is currently the most important water source for Davao City, with its aquifers serving 99% of the city's demand for water. Aquifers are underground layers of water-bearing permeable rock, rock fractures, or unconsolidated materials. When water is absorbed by the ground, usually from the higher elevations such as mountains with full of vegetation. The vegetation, soil, and other rock formations underground filter the water, making it cleaner than the water found on top of the ground. The volume of water aquifers may differ from place to place and according to geological formations. The physical template of watershed structure is ultimately determined by varying combinations of climatic, geomorphic, and hydrologic processes. The three elements of physical template and other factors also interact significantly in determining the structure and composition of a watershed and its biotic communities. In this diagram, the figure 5, the strength of influence on the watershed is represented in two ways. The relative size of the arrows and the level of control indicated at the right side of the diagram. As a result of different combination of these formative processes, varying types of watersheds are created, differentiating from other watersheds of different origin and physical template conditions can be. So these are the guide questions and objectives of this report before proceeding to the main topic. So these are the guide questions and objectives of this report before proceeding to the main topic. First is, what is a black box model? Second, how black box models help hydrologists to create a hydrograph in a watershed. And the third, what are the different common types of black box models? Vito Belevich and Franz Breisig put the concept of black boxes in 1921, explaining the concept to two-port networks as block boxes, and argues that two terminal components were implicitly created as block boxes. William Cower published these ideas and developed them in 1941. The word block box was first used in the English language around 1945 in electronic circuit theory, wherein the process of network synthesis from transfer functions which led to electronic circuits being regarded as block boxes, described by their response to signals applied to their ports. Black box in general is a system which can be viewed in terms of its inputs and outputs without knowing the internal processes between them. This term is also used to refer to internal processes in such as the ones of a transistor in electronics, an engine in mechanical engineering, an algorithm in computer programming, the human brain or institution or government. To analyze a system using a black box model approach, only the behavior of the stimulus and the response will be accounted for to have a conclusion of the unknown box. The typical representation of this black box system is a data flow diagram centered in a box. The modeling process is the construction of a predictive mathematical model using existing historic data or observation table. Modeling process. According to Dime and Ivy in 1980, there is a simplified version of the modeling process from a problem to its solution applying the scientific method as shown. This is the kind of modeling process that involves with the real and conceptual world. The real world is the actual condition of the problem or the situation, while the conceptual world is the ideal situation that can be modeled using controlled environment and observation to arrive at an ideal analysis. These two worlds should correlate with each other and for better understanding of the model. According to Quarteroni, the different aspects of the real world can be described using mathematical model following the scientific method as described in this figure. The figure 8 modeling process was based from Carson and Covelli, which poses the necessary questions for a successful creation of a model such as 1. Why, which identifies the need for the model. 2. Find, list data researchers are seeking. 3. Given, identify the available relevant data. 4. Assume, identify the circumstances that apply. 5. How, identify the governing physical principles. 6. Predict, identify the equations that will be used, the calculations that will be made, and the answers that will result. 7. Valid, identify tests that can be made to validate the model and if the results are consistent with its principles and assumptions. 8. Verify, identify tests that can be made to verify the model. In conclusion, whatever the researcher used for modeling according to the application, it can vary from policy analytical to scientific research models or operational models for real-time control of structures. However, the mathematical model must be able to address universal scientific concepts to fully define the different parts of the model. According to Penman, the model of hydrological process can be shown using block box method to answer a single question. What happens to the rain? This may be answered using a simple hydrologic cycle using figures 1 and 2. However, based on experience, quantitative descriptions of various factors such as land phase is very complicated. Most black box models are focused on the watershed hydrology, which is a branch of hydrology that deals with the hydrologic processes at the watershed scale to determine and understand the laws that rules the watershed. By definition, a black box model is a fitted mathematical representation of a system without regard to processes. The characteristics of such device usually are developed from observation of inputs or outputs. They don't identify or simulate process involved. Usually they are statistically based. Regression and in hydrology, rainfall is input and runoff or discharge is output. And as examples, we can conclude the rational equation and the unit hydrograph. The purpose of this section is neither to provide a complete discussion of the theory of black box systems, nor to offer a complete coverage of the said topic. Rather, this focuses on presenting general theories of different types of black box models with different variables for inputs and different results as outputs. The first type of black box model is Antecedent Precipitation Index Model, or API. It is a model developed based on water balance equation capable to predict runoff yields from ungauged catchment when its parameters estimated from gauged catchment are updated using the linear relationship of geomorphologic parameters of an ungauged to that of the gauged catchment and cumulative geomorphologic index, or CGI. The second type is regression model. The variables to analyze and predict by regression are peak flow, runoff volume, and runoff coefficient. The predictor variables are peak gauge average rainfall, total event rainfall volume, rainfall spatial variability index, base flow as an index of antecedent conditions, and distance of the rainfall centroid from the flow gauge. The third type is time series model. The principal aim of time series analysis is to describe the history of movement in time of some variables such as the rate of flow in a river at a particular site. River flow and other hydrological sequences are characterized by variability and oscillatory behavior. This highlights the importance of studying time series, the properties of which are of great significance in the planning, designing, and operation of water resource systems. The fourth type is the Artificial Neural Network Model, or ANN. This is a soft computing model which has been widely used to model complex hydrological processes such as rainfall runoff, and have been reported to be one of the promising tools in hydrology. The significant input variables for training of ANN models were selected based on statistical parameters, cross-correlation, autocorrelation, and partial autocorrelation function. The fifth type is the fuzzy logic model. This is a soft computing model which is a well-known tool which develops the workable algorithms by embedding structured human knowledge. It is a logical system that presents a model designed for human interpretation modes that are inexact rather than precise. It can be applied to design intelligent systems on the basis of information expressed in human language. And the last type, the frequency analysis model. The frequency analysis of hydrological extremes requires fitting a probability distribution to the observed data to suitably represent the frequency of occurrence of rare events. The choice of the model to be used for statistical inference is often based on subjective criteria, or it is considered a matter of probabilistic hypothesis testing.